as always, we want to talk about tapping into your math genius. My co-hosts are going to be joining me a few minutes late tonight, but you guys are familiar with this. We've been doing this several weeks now. If you come across my video and by chance you're connected to my co-host and you're not aware who I am, my name is Lanisha. I am a district math coach here in North Carolina, supporting schools in Cumberland County. And I'm also a teacher leader in residence for Open Up Resources. And I also run my tutoring business as well as facilitating summer camps for the kids. We just wrapped up 3 cohorts this summer and super excited about the data that came from that. I think that we're moving in a really good direction. Okay, so excited to be on here with you guys tonight so that we can continue our conversation about those number lines. So before we move on, I just want us to review, what did we talk about 2 weeks ago? So when we started this conversation, we talked about the progression of number lines, right? And so we told you guys that kids start seeing those number lines in kindergarten, all right? As early as 5 and 6 years old, they're already seeing and conceptualizing that number line. Now, what are they seeing? They're seeing that number line sometimes starting from 1, so like those natural counting numbers, or sometimes even count starting from 0, right? So they can start to understand that 0 is nothing, right? And using that to compare other quantities. And then as they progress along through elementary school, they're still looking at kind of that right side of the number line. I mean, those positive numbers. And then once they get to 6th grade, they're then looking at the left side as well. So now they understand that we now have negative numbers. I went to a conference last week in Denver, Colorado. I facilitated 3 sessions out there, but then I also had the opportunity to attend some of the sessions as well. And one of the sessions that was super memorable was about how students learn about things that expire. So sometimes they may run into an elementary school teacher that says, you can't do this or you can't do that. And an example is, you can't subtract a larger number from a smaller number. Now, that's one of those things that expires, because we know that when they get to middle school, that's no longer the case. They're going to be seeing situations where you can subtract that larger number from a smaller number, and it just means you're going to be on the left side of 0. Okay, so again, once the kids get to 6th grade, they start to see those negative numbers. They also start to see double number lines as they start to compare quantities. That double number line then starts to create that coordinate plane, and we see the X and Y axis. And then that's pretty much where we kind of left off and where we're going to pick up tonight. I see that I am now joined by one of my partners here, Dana Harris. So Dana, if you wouldn't mind, just come off and introduce yourself to the people.
Can you hear me?
Yes.
First of all, okay, I got some new audio, and I'm excited about it.
That lighting is popping.
Yeah, so we working on the studio. But first of all, what's going on, Niche? Good to be here. My name is Dana Harris. I am the Chief Academic Officer of Young Gurus Math Tutoring, which is an online math tutoring program for students in grades 6th through 9th. We make adjustments based upon the needs of students as far as grade level. But my focus is typically pre-algebra and algebra. However, my experience, I have taught everything from 7th through 12th grade, and I have been a math facilitator at the elementary level. And I am always glad to join in on these talks. Nisha, I see you giving the folks a preview from what we talked about 2 weeks ago. And I'm excited to get into the conversation tonight.
Let's do it. Let's do it. So our other partner will join us a little later. So we're going to go ahead and jump into it. We already talked about what we discussed a couple weeks ago. So I want us to go ahead and jump into our math myth buster for this evening. So if I ain't quick with it, I'm not good at it. So I think that this is a belief system that some people have surrounding math. But Dana, I would like to know your 2 cents on this. So if I am not quick with my calculations, with processing in the classroom, with processing mathematical concepts in general, I'm just not good at it.
I think that's definitely a myth. And one of the reasons that I say it's a myth is because the brain takes time to process some things longer than other things. And so a lot of times when it comes to the way mathematics is set up in the classroom nowadays, there is a reading comprehension portion that comes along with it. And so sometimes some kids need a little more time to process the wording of the scenario that they're given. And then from that scenario, if they're in elementary level, maybe they still have to create an equation. Maybe they have to figure out what strategy they need to use. And
Mhm.
then after they figure out what strategy they need to use, they got to work through the strategy. And so that takes time for the brain to process things. I think the at the middle school and high school level, it gets even deeper. But the most important part about busting this myth, in my opinion, is the aspect of mathematics now is a lot different. It's not what I like to call naked math. So it's not just solving equations, right? And
Mhm.
so when you understand how mathematics has changed, I think a big part of what makes kids think that if they're not quick with it, they're not good at it is because they're timed. When you think about state assessments, they have a maximum amount of time that they can take. And
Mhm.
so I think that's why it's very, very important for us to get kids to having these conversations to where they're thinking out loud. It's kind of like the kid that, after a certain point, you're no longer reading out loud in class for the most part. You've got to read inside your head. And so that's where the connection to learning how to write down different things, highlight, underline, circle, know vocabulary, and things like that. So you're not going to always be quick at math. There, there are concepts in math that I still am not the quickest at, but efficiency is more important than speed.
Absolutely. So I'm just going to revoice some things that I'm hearing here. So efficiency is obviously better than is better than speed, right? That's one thing that I'm hearing from you. Another thing is that there is an element of time that we have to consider because of the fact that we're taking these standardized tests that are timed. So
Yes,
unless we have some type of accommodation that says we get extended time, there is kind of sort of a I need to go in with the I have this much time that I need to spend on this. And it isn't
absolutely.
just and it isn't just school-based tests, because when you think about ASVABs, when you think about other kind of standardized exams outside of primary and secondary education, there is still that time component. So maybe there is some processing that we have to say, no, you don't have to be fast with this because everybody has a different way of processing. But maybe there is something kind of in the back of your mind that I can't take 2 hours on this now because I still got 40 more questions I got to answer. So I guess maybe finding the balance, maybe.
Yeah, and that's where the practice at home and independently plays a major role. Because I like to say kids a lot of times get caught up in the weeds. That's why when we talk about these different things about students knowing um, math facts of your
Mhm.
basic four operations, that's where those things play a key role. Because when you have to spend less time processing those basic math facts, you can focus more on figuring out a strategy for solving the equation or for figuring out a solution. And then you can also take that time to really do the other necessary things.
Right.
And I love what you said about the fact that even outside of primary and secondary education, there is a level of standardized testing that many people have to do in just about every profession.
Yeah.
Like if you're going to work in a profession where you're going to make some money, you definitely are going to have some type of education curve and you're going to have to learn and be taught what it is that they want you to do. And if you want to get better at it, you definitely got to learn fast.
Right. Absolutely. Yeah. I think um I think like you said something about facts, whenever I was growing up, we had to do like our multiplication facts or whatever, and there might have been like a time associated with that. And I know a lot of teachers were still doing that in some areas, and maybe parents were complaining about that. And I
Hmm.
think that there is a level of pressure that might be associated if you have a child or if you are a child who doesn't process as quickly. But like you said, some of those basic, those foundational skills, you do want to get really automatic with it. You really do want to get kind of second nature with it so you can apply that energy somewhere else. So I'm glad that you brought that up because we're not saying, take all the time in the world. because you really do want to practice, 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 as Dana was saying. You really don't want to practice so that we're not wasting energy on things that really should be kind of built in, kind of have some muscle memory to it.
And on top of that, you just made me think about something when you said automatic.
Mm-hmm.
Automaticity
Mm-hmm.
is a buzz. Well, it's not even a buzzword. It's part of a lot of the elementary standards.
Exactly.
And some of the like there is a standard. I can't think of what grade where the standard says that students should know certain things with automaticity.
Right. Mm-hmm. Absolutely. Especially when you're talking about those number bonds or those number partners within those certain bands of numbers, so like 0 and 10, knowing all the ones
Absolutely.
that make that, you should automatically know that. And it's unfortunate, but I'm still encountering students in middle school, and I've said this before, that you will ask them plus or minus one, and they have to pause and think about it. So if I don't
Absolutely.
know what is one away from a number, then obviously if I'm now talking about 3 and 4 or 7 away, that's going to be even more of a challenge. So I
That
think the
part.
number line really helps kids to visualize that so that they can see, like, one away just means it's right beside it.
Yeah,
So,
exactly.
you know what I mean? So I think us talking about this is only going to help ground it for the parents. I see that
Absolutely.
Akil has joined us. Akil, if you could go ahead and introduce yourself. I hope you're at a safe place. I don't want you to be driving and trying to maneuver your camera and your V at the same time.
So, brother number one is here.
No, it's good. I'm my phone is in the holster. Yeah, I'm Akil Parker, founder and CEO of All This Man, and I teach on YouTube. So check out my YouTube channel. And I'm a father of 3.
Okay.
Trying to share the things that I've taught my children and am teaching my children with everybody else.
Absolutely. Thank you so much. I'm gonna revoice some of that because I think it was cutting out a little bit. I know he has All This Math YouTube channel where he's teaching you guys what he's taught his children. So the things that he's sharing are things that he knows to be true and things that he knows to be effective because he's doing it with his kids. I know he also says that he is a father of 3, right? Did I get that number correct? It's 3 of them. He has
Right.
hystematics going as well as a book that he has out as well. So both Dana and Akil are putting lots of content out there to support parents at home. And I think over these last several weeks of us being together, we've really been trying to hammer and emphasize how important it is for parents to be those teachers at home. So not really relying on the things that are happening at school, but taking a more active role. So if you feel like you don't know where to start, those are 2 very good YouTube channels. I know both of them between each other probably got several hundreds of videos to choose from. So if you don't know where to start, please check out Young Gurus Math Tutoring as well as All This Math on YouTube.
We got between the 3 of us, we got easily 1,000 pieces of content that students and parents can utilize as resources.
Absolutely.
Between the 3 of us.
It's a lot out there. It's a lot out there. So I really don't want parents to ever feel like I can't ... because the resources are out there and it's free. You know what I mean? It's free. So there's no barrier right now in terms of finances. Go to YouTube.
I'm ready to do Proud to Pay, y'all. I'm ready to do Proud to Pay. I'm gonna get on that Nipsey hustle.
So look, while it's free, you better get in where you fit in.
That's it. Because I'm telling you.
All right. So earlier in the session, we talked about how, in kindergarten, kids are seeing that number line. In a lot of states, we're starting from 0. Once they get to 6th grade, they're now seeing that left side of the number line, getting into those negative numbers. Then they start to see those double number lines where they're comparing those quantities. And then that double number line starts to create those perpendicular lines where we create that coordinate plane with the X and Y axis. And that's pretty much where we finished last time. So when we got here, this is a 6th grade concept where students start to talk about vertical and horizontal distances. So prior to this, they already had exposure to the number line. They've already been using it for several different things. So now we're looking at shapes within that coordinate plane and talking about those distances. So in order for a child to do well, to be proficient in figuring out a horizontal or vertical distance, what is it that we want the kids to know when they're looking at this? What do we expect them to know?
I think first they need to first have the math vocabulary, or we can call it math vocabulary or general vocabulary. Knowing what vertical horizontal means.
Okay.
First and foremost, I think that's one of the things that like I might have taken for granted in the past, that they would know what the word vertical means and know what the word horizontal means.
Mm-hmm. Mm-hmm.
As,
What else we got?
as some fundamental.
What else we got, y'all?
The scaling.
Mm-hmm.
Scaling is important. Are we counting by ones? These are the things that, you know, I'm working with my daughter, Asada. You know, you'll see in the YouTube, a lot of my YouTube content. She's going to the 7th grade in August, well, next month, actually, not even September no more. Kids go to school in August now, at least up north. Y'all, when do y'all start? Y'all start like early August, right?
In about the 3rd week of August for us.
Okay, so we starting around the same time. But yeah, she has a summer math packet, which also I want to say, like, parents, like, be thankful if your children were given a summer math packet by their school. And if they weren't given one, I would say it's not too late. Go online and find one, and just, you know, be proactive. Just have your children practice some math on a regular basis, you know, leading up until when school starts. Because those summer math packets are clutch, right? They really come in handy. But I'm helping my daughter with her summer math packet, and one of the things we were doing today was solving and graphing inequalities.
Mm-hmm.
So just, you know, introducing her to the number line that ties into this conversation, and also the conversation we had in our last session. You know, how you know, understanding the scaling of the number line. Also, you know, and one of the things that she brought up was, like, I was trying to show her, it was a virtual session because, you know, she's in Philadelphia with her mom and I'm in Baltimore. I was in Baltimore earlier today, and she was kind of concerned about like, what number she should put on her number line. And what I was telling her was, I had to explain to her, like, once you find your boundary point, as in, like, once you solve the inequality, like, if it's x is greater than 12, then 12 is your boundary. And then you basically can just, like, you don't have to worry about, even though, like, what children are accustomed to is, like, seeing the number line with 0 in the middle, and then it goes 1, 2, 3, 4, 5 to the right, and then it might go -1, -2, -3, -4, -5 to the left. But if a boundary point is 12, then it's like, that's what she was getting frustrated about. Like, well, where am I put the 12 at? Like, where's it gonna go? And I told her, I said, well, you can just do your spacing based on your boundary point. So if your boundary point was 12, then to the right, you could put 13, 14, 15, 16. Maybe to the left, put 11, 10, 9, 8, 7, you know? And because the real issue is just showing that you know where the solution set is. Like, you know, if X is greater than 12, then where are you drawing your line at? Is your line going to the right, or is your line going to the left from the boundary point? So things like that.
Gotcha. So I think that was one of the things we talked about last time, is like being able to take that snapshot or that screenshot of that number line and just focusing on just one section of it, versus kids feeling like I need to write every single number that exists on the number line ever. Just kind of making the decision what makes sense based on the situation that we have. Thank you for sharing that. So what I did here is I had put 4 points on the coordinate plane, which is going to kind of go into like recognizing the shapes in the coordinate plane as well. I went ahead and labeled each of those coordinates. So if we're talking about the vertical and the horizontal distances, what are we expecting the kids to be able to do? You muted, Dana.
I think my perspective is, so when I look at the order pair 1, 1, and the order pair -2, 1, right? They're so closely related, like, because the y coordinate is 1, it's almost like in your mind, you have to shift that x-axis up 1 so that you can count those distances. I think that's one of the things that confuses students a lot of times, is they get caught up in the spaces when there are no grid lines. As long as they have grid lines, they realize, like, oh, it's just a bunch of number lines that are vertical. that are parallel to one another, and a bunch of vertical lines or horizontal lines that are parallel to one another, right? But when you have a number line like this that does not have the grid lines, you can almost imagine yourself shifting that axis up and shifting that y axis left and right. So I think that's something that's very, very important for kids to be able to visualize in their head. I think also, depending on the grade level, by the time they start asking them what kind of shape this is, the students have been introduced to vertical lines. I'm not vertical lines, but parallel lines and perpendicular lines. So, like, for example, we can look at those 4 points and make the assumption that it is a rectangle. However, you don't want to, my 10th grade geometry teacher, Miss Williams, she always told me the first rule of thumb in geometry is to never make assumptions. Everything has to either be stated explicitly or it has to be proven. And so I think it's very, very important for them to understand that concept of parallel lines and also understand the traits that come along with each shape. For example, well, what's the difference between a rectangle and a square? They both have 4 right angles. However, the difference is the square has 4 right angles and 4 congruent sides. The rectangle doesn't. It only has the 4 right angles, and then it has the 2 pairs of parallel sides.
So one thing that stands out to me is, you didn't say this, but this is what I'm hearing: translation. Like translating that x-axis up, which the student in 6th grade wouldn't have heard that yet, but I'm thinking 8th grade, which is where we're going to eventually go with this number line anyway. I'm also thinking about the fact that you highlighted the fact that those 2 top pairs, ordered pairs, have the same y-axis. I mean, the same y coordinates, excuse me. So when we're talking about the distance of that line, we really only have to focus on the distance between those x values.
Absolutely.
So then once students figure out what the distance is from this one, and then they see that the opposite side measures the same thing, and then maybe they'll do the same thing for those vertical sides and see that they are the same, then do you think that's sufficient enough for them to say that it's a rectangle?
Not exactly, because they have to prove that let's say that top side, it has to be perpendicular. You've got to prove that it has the 4 right angles. You see what I'm saying? And so I can't recall the 6th grade standards right offhand, but you can say that those opposite sides are congruent, but if you can't prove that those are right angles, then now it becomes easily a rhombus. You see what I'm saying? So I think also, as you were saying what you were saying, it makes me think about the kid that is counting the distance on one side of the number line in the positive direction, and the side on the negative, the distance on the negative side of the number line. They have to remember that distance is always positive.
Yes.
And I like to use the example when we start talking about absolute value, right? I always use the example of driving in a car, and I say, hey, well, look, if I put the car in reverse, and I could drive real well in reverse, y'all, by the way. When I put the car in reverse, the odometer doesn't go in reverse. I wish it did. I wouldn't have 350-some thousand miles on my old car. And I wouldn't have as many miles on my new car either. But they have to remember that distance is always positive. So now, to your point, we can take the positive distance from 0 to 1, that's 1 unit. And then we can take the distance from 0 to -2 and realize that that's still 2 units. 1 unit plus 2 units gives us the 3 units. And it's the same thing for those vertical sides. The distance from 0 to 1 is 1. The distance from 0 to -3 is 3. So then that means those sides, if we add the 1 and the 3 together, gives us a length of 4 units.
So then another thing that they could do, like once they get those side lengths, they could get a question like, what is the perimeter of this figure?
Absolutely.
Okay. And then what, also area too?
Yeah. Yeah.
Okay. All right. So I had shown the rectangle and then the square, but I'm gonna have to go back to the drawing board on this. I looked in it and I thought that it said that they should be able to construct shapes in the coordinate plane, but I know for a fact that sixth grade is not doing anything to prove perpendicular sides. Like I
Yeah,
feel like,
that definitely sounds
yeah.
like a stretch when we talking about sixth grade.
So
Yeah.
I gotta see, I need to look up what the specifics are with them verifying those shapes in sixth grade. So we'll come back to that and address that at a later date. But I did pretty much the same thing with the square. So them, the square, I'm doing this now, the square. Which again was going back to those vertical horizontal distances. And I know that when they're doing this, the main thing that they want kids to understand in the sixth grade is that if it's a horizontal line, that there is a specific coordinate that is the same. If it is a vertical line, then there's also a specific coordinate that is the same. And so that way, once they see that, they know which one they need to focus on. So that was one of the main things with that, those vertical and horizontal distances.
Can I say something real quick?
Yes, absolutely.
So I just wanted to say that when you was talking about being very proficient at driving in reverse, you took
Your phone breaking up a little bit, Akil. Your phone breaking up. All that goodness that you're saying, we can't even hear
Yeah,
you.
you're gonna have to
to
repeat
the
it, bro.
Biggie hypnotized video, driving back. You know?
Now we
All
can.
right. Now you can. All right. So I was saying, Dana, you took me back to 1997 to the Biggie hypnotized video. Him and Diddy in the convertible driving backwards in Miami.
Yeah.
In the convertible. It just made me think of that.
Mm-hmm.
But I also wanted to add on to like the issue with horizontal lines and vertical
Mm-hmm.
lines. I try to use it as an opportunity to like address math language, and in terms of like treating math as a language and trying to translate from the language of math or the English language into the language of math. Because if you talk about the equation of a vertical line, like it might be x equals 3. If we convert that or try to translate that, we're saying that means x will always be 3, right? Or x is 3. So no matter what the point is, the x value of that point is going to have the x coordinate is going to be 3. Likewise, with a horizontal line, you may have y equals 3, might be y equals 3,
Mm-hmm.
right? Meaning y will always be 3, no matter what the point is. But just like it's an opportunity to like show, like visually, I like showing it visually and graphically, and at the same time having like using the English language as a way to like indicate like, okay, like almost like using the English language as a proof of what we're doing, of what that equation really means.
Mm-hmm.
Did y'all hear me or did I break up?
No, we heard
Nah,
you.
we heard it. That's important. That language piece is so important. I think that's what throws a lot of students off because they're not always used to the language portion.
Right.
And we understand that algebra especially is a language. And when you understand the language, it makes a difference. And I love that analogy because like I have more over the past several years, I've had more and more students that English is not their primary language. And one thing I love about math is that if you give them some calculations, oh man, they gonna go in. I think that's one of the challenges for native English speakers as well as people that speak English as their second language. That language, when it comes to mathematics, is very, very important.
Mm-hmm. Yeah. Two things I want to hit on. Akil, you said something about like the horizontal and the vertical lines and the equations of those lines. I think students start to get into that in 8th grade, if I'm not mistaken. Dana, you can chime in if you remember exactly, but I think it's 8th grade when they start to get into that. So in 6th grade, It's more so the students recognizing that when they're looking at that polygon within the coordinate plane, that those horizontal and those vertical lines have that shared coordinate, but I don't think it is the equation part yet, not until 8th grade. The other thing I wanted to say is with the drawing of the polygons, when you were saying earlier that we have to prove that it is a square or a rectangle, I had to, how to get my Googles on. So how they know for a fact that it is a square or a rectangle is because it actually does have the grid in the background. So you see my image here is blank because I was being lazy and did not draw an entire coordinate plane with all of the squares that you mentioned earlier. So when they do it on the actual grid, because it's a square, you know that it creates that right corner there, that right angle in the corner. Does that make sense what I'm saying, or do I need to share my screen?
No, that's a very important fact. I think that's very important because you can see that they're actually parallel and perpendicular when you have those grid lines in the background.
Yes.
Like it's without a doubt.
Okay, so hopefully parents understood that. I'll put a link in there, I'll put an image in the comment section so they'll be able to see that. But yeah, thank you for bringing that up in terms of we don't ever make assumptions. We want to make sure that we have some proof there or some evidence to that regard. All right, so earlier in the session last week or a couple weeks ago, we started talking about those proportional relationships. And I wanted to put this slide after the proportional relationships because we could graph them, but I was trying to be real strategic with what I was doing here, because we went from students understanding or trying to figure out things about horizontal and vertical lines, and then we're going to these diagonal lines in a sense, maybe not necessarily in order that way.
Yeah.
But I wanted to talk about these proportional, and I have two slides here, one with the negative slope that you see here, one with a positive slope, and then I have some non-proportional ones as well. So when we're talking about these relationships, again, we do still have the number lines here, obviously, because we're in the coordinate plane. But what are some things that we expect for students to know and be able to do when they're presented with this type of information?
First of all, I like the fact that you talked about negative slope and positive slope, right? So I think that if a student can recognize that a line that slants downward from left to right, kind of like we read from left to right,
Ooh,
if it slants downward, then it is a negative slope. If it slants upward from left to right, it's a positive slope. And so those things are very, very important when we talk about these proportional relationships, because if we're getting into the slope of this line. Now, the ultimate goal is for them to understand that the slope between any 2 points on a line is going to be the same. Now, when we see, hey, this is a negative slope based upon this visual cue that we have, now, once we put some points in there, that proportional relationship may be negative 3/4. And then now they can see, well, okay, well, negative 9/12 has the same proportional relationship. They're both going to be negative or they're both going to be positive. So I think that that's very, very important to be able to see the difference between positive and negative slope visually.
Absolutely. So I want to say something, and I'm not being a jerk. I'm saying this only because I had to say it to myself. I used to always tell kids, you read the graph from left to right, because just like when you're reading the book, you read from left to right, right?
Yes.
So
hear you out. How you say it?
Hear me out. Corbin is really into Naruto. I don't know if your son or either of your sons or anybody you know is into like Japanese literature or anything like that, but their books.
No, I got an athlete and I got a comic book kid.
Gotcha.
But neither one of them are in it. Like I think the most I'm still trying to learn about all of these different Japanese cartoons and what's the term they use for
anime.
Listen, if they say they were gonna give me $1 million to answer some questions about anime, don't put me on Who Wants to Be a Millionaire.
You said don't worry about it. Okay.
Don't worry about it.
So he got we bought some Naruto books. So there were some novels or whatever.
Uh-huh.
When I looked at the book, I was like, there's something wrong with the book. We ordered it off Amazon. I said, there's an error with the book. My son said, no, it's not. Yes, it is. The book is upside down. He
It's
said, no,
Japanese.
that's how they read the books.
Yeah.
There.
Oh man. Oh man. You know what? That's a good. I'm glad you said that, because here's why that's so important. Because there's so many kids that are in the anime. And I love that's a great revelation for me, because Japanese characters, they read different than we read English characters. And, and mathematics is a universal language, right?
Right.
Similar to music. So man, thank you so much for that. I'm gonna have to, yeah, I'm gonna have to put that one in my toolbox, because
yeah. So it feels like you reading from right to left because the book is backwards.
Ooh.
So when you hold it the same way you would hold an American published book, an American book, it looks like it is upside down.
Really?
Yeah. So when I saw that, I was like, oh my gosh, I've been telling kids, you know how we read left to right?
Flag on the play. I'm guilty.
So when we talk about things like representation or using inclusive language, there's some things that we don't even know about. You know what I'm saying?
That's
like there's
true.
some things we don't even know about and don't even know we're not including the kids. So I just want to share that with you.
No, that's a good share. I like that one.
All right. So thank you for mentioning you want the students to understand the negative slope. I put a little man up there so we know he's walking downward. But one key thing that I really would love for kids to understand about this is as X increases, Y decreases. I would love for kids to be able to make that connection. And I don't think sixth grade is too early for them to do that. You know what I mean? Like, even though we're not talking about proportional relationship, when we're talking about different ratios, like the more of this I add, the more of that I add. Right. You know what I mean? Like, I think we can still have those conversations in sixth grade as well.
Absolutely.
So now, on the flip side of that negative relationship, now we got the positive slope. So Akil, thank you for joining us. Dana talked about the negative slope and things that he would want kids to recognize with the negative slope. So what are some things that we would hope that kids would be able to know, understand, and be able to do with the positive slope or a representation like this?
Well, understand that it's I don't know if y'all said this already when I had logged off, but that it's going uphill. So if it's a positive slope, it's going uphill. But here's the thing though. So, because this used to confuse me when I was a student, or it confused me until somebody explained this to me. Because it depends on your orientation, which way you're looking at it from. Because if I'm looking at it from the right to the left, then it's looking like it's going downhill. But if I'm looking at it from the left going right, then it looks uphill. So making sure that students understand that we're looking at this from left to right. Because looking at it from left to right, and that affects the downhill lines too. So the negative slope lines also. So it's about the orientation.
Okay.
So that's one thing that I try to point out. Make sure you're looking at it from that perspective, going from left to right, because left to right will influence if you're going uphill or downhill.
Mm-hmm. So previously we said with the negative slope, as X increases, Y is decreasing. So if it's a positive slope, that means as X increases, Y is also increasing.
Right. And that's, that's good too. What is it? As X goes toward, I'm trying to think. It's like an algebra 2 / pre-calculus concept. In behavior of polynomial functions. I know this is like kind of beyond the scope, but it's like what we talked about in our last session. Mm-hmm. Teachers being able to make connections to topics that are more advanced and that the students will see in subsequent classes. So the students being very comfortable with the Cartesian plane or the XY plane or the coordinate plane, however we want to call it. When we talk about like end behavior of polynomial functions, and you might be talking about like something like X to the 4th power or X to the 5th power, X to the 6th power, but you just want to focus on the end behavior, as like, as X increases, as X goes toward infinity, what does Y do? Like, does Y go toward infinity, toward positive infinity, or does Y go toward negative infinity? Mm-hmm. So those types of things. So this is kind of foundational, mm-hmm. So it's like very important. I'm just the more and more I think about it, like this right here, like the XY plane and just being, I think we should spend, just as a society or as a math community, we should spend a lot more time on just really drilling deep into understanding the XY plane.
Yeah.
Because so much that comes after it that requires a solid, as like a very solid understanding of the XY plane. And when students don't have a solid understanding of the XY plane, it just causes so many problems. It's almost like it's so important to put in the work on the front end, because so that you'll be cool on the back end.
Yeah.
And even if we have to sacrifice, I mean, that's the hard part, understanding, just making decisions about curriculum and scope and sequence and whatnot. But maybe you got to like cut something else out of the curriculum to focus more time on this. Because really understanding like and being very comfortable with like the XY coordinate plane, it just it's so relevant to like everything. Because even when you get to calculus and you gotta like you're always gonna have to graph. We always gonna have to graph. We have to graph everything. And we're gonna have to see what the functions look like. And even that, the functions, like, is it like we talk about the vertical line test, like, is it a function? Is it not a function? Like, what makes it a function? Like, just like these, and sometimes I know in the past, like, there have been times when I didn't spend a lot of time making sure students really understood the XY plane. And I might have been following the scope and sequence that was given me, and I might have been a situation where I didn't know any better. I didn't know that, well, no, they need more time with this, or they need to get a deeper understanding of this. But yeah, I want to put that out there because this is so foundational.
I think that this is even a concept that parents could definitely tackle at home. So like if you lived in a neighborhood or a place with like blocks, I think just setting what your origin is, like what's going to be your ground zero, where you starting at, and then from there, like when you're moving to different locations, assigning those the scales and stuff to it. I think that is something that parents could definitely do, depending on where you live and what you have access to, that they can make it like an adventure. Like this could be a field trip of things where you're just understanding location and coordinates and things like that, like doing it real life with you moving and then applying it back to paper and doing things online. I think it would make it so much easier for the kids to understand it when they get into the classroom, because they've been doing it at home with mom and dad and whoever else.
Yeah.
And even if you don't live in the inner city where there's typically blocks, if you have tiled floors, or if you have even the linoleum, the different types of floors, typically the squares on the floor are the same size. Old school, it was all just squares. But even some of the fanciest tiles have squares and they're equidistant apart. So that's another area where you can practice it. Even if I'm looking at my blinds. Like the blinds, you could really kind of flip that if your kid has an understanding of it, and show them how when you open those blinds up, they're parallel, they're equidistant apart. And then you could kind of, depending on how deep you want to go, the little string that goes down the middle of the blinds, that center string could be your y-axis, and then maybe you can use the middle of the windowsill as your x-axis. It's just a matter of how well your student can visualize it and how you can make that connection.
Oh, I can do that with my window too. My window.
Exactly. Yeah.
My window
like
pane.
even if you, like.
So now,
So many opportunities. One of the things I used to do is like, so if anybody's familiar with like Philadelphia and SEPTA, Southeastern Pennsylvania Transit Authority, I think is what SEPTA stands for. So the subway system. So well, SEPTA has a subway. The subway runs north and south along Broad Street. So I would tell the students, like, when you go down to the subway after school, take a look at the map for the subway and the elevated line. So the elevated line runs east and west. So we call it the L. The sub runs north and south. We call it the sub because the subway goes underground, even though the L goes underground also, but it's not only underground. Like the subway is only underground, right? The L is above ground, then it dips underground when it goes through Center City or downtown, and then it comes back above ground again. So the L would be the x-axis, and the sub would be the y-axis. And I would tell them, like, look at the different stops. So different stops on the sub are different numbers or coordinates on the y-axis, and different stops on the L are coordinates on the x-axis. And then, of course, even they have like Philly has like a regional rail system, which kind of branches off. And then I guess if you get real specific, like the bus routes and everything, like all of those would be different coordinates in each of the quadrants of the XY coordinate plane. So, yeah.
So now your kids have an opportunity to look at X and Y intercepts. So
Mhm.
imagine how a student would feel if they go into the classroom and we're talking about X and Y intercepts, and they already been talking about that with their parents. They already been talking about that at home because they've been doing these field trips, or they've been doing whatever these activities are as a family. Now I'm in the classroom talking to you. Oh yeah, we do this when we on the L train or whatever it is. Yeah, this whatever the story is, whatever stories y'all got up there. This is what this is. That would be considered a y-intercept because it falls on this or whatever the case may be. Imagine how empowered that kid is gonna feel in the classroom when they're able to engage to that level in the conversation. And they always talk about funds of knowledge. Like, what do kids come in with? The kid is gonna come in with even more if the parent understands how they can kind of make it their own at home and introduce these topics even before they get to the school.
Absolutely.
All right. So we talked about number line from kindergarten, 0 up, get to 6th grade. Now we see the numbers on the left side of 0. We talked about these relationships when we're looking at ratios with the double number line. We take the double number line, we turn them into those perpendicular lines to create the X and Y axis. We're now plotting points within the coordinate plane. We are looking at horizontal and vertical distances in the coordinate plane, understanding that if it's a horizontal line, that those Y coordinates are the same as the vertical line, the X coordinates are the same. Then we start to look at proportional and non-proportional relationships when we get into 7th grade. Now, the students have not learned this terminology of translation yet in 7th grade, but if I'm talking about like a parent function and then comparing that to one that's non-proportional, we could consider that a transformation or translation there as well. So when we're looking at these non-proportional relationships, I think, if y'all want to agree with me, the things that we want them to know are pretty similar to the proportional ones. It's just the fact that it's not going through the origin. Is there anything that y'all want to add on to that?
No, I think that's it for me. Like that's the key, that going through the origin when we're talking about proportional relationships.
Okay. All right. So we got
And
our positive and negative slope. Akil, what were you going to say?
and so in that equation, the y-intercept wouldn't be written because you don't need to write +0.
With the proportional relationship.
Right, with the proportional relationship, yeah. So I guess a way to like now do you get into direct variation? Or do you talk about direct variation when you talk about the proportional relationships?
We don't use that terminology in Cumberland County. I don't think it's in our standards in North Carolina, period. They're just using proportional versus non-proportional. But I know there are some test questions in our test bank that have direct variation, but they always tell us in Cumberland County to remove those because it's not in our curriculum.
If it is, it's in Math 1, and they talk about more the constant of variation because of its relationship to the slope. Can't remember exactly where. I want to say it's not. I don't know where it is because North Carolina's been mixing stuff up so much lately.
They can talk about it in 7th grade. We just don't. We just don't use that terminology.
Okay.
Yeah. All right. Okay. So still progressing.
Real quick, can I ask?
Yeah.
Do you in North Carolina, do you use inverse variation? Do you use that terminology? Okay.
Nope.
Not in middle school.
Okay.
So just finished talking about proportional, non-proportional relationship. We already talked about horizontal and vertical distances. Well, now what type of shape? We're going to pretend like there's grid lines in the back because we want to make sure we got evidence here to prove what this shape is. But what shape do you think this would be?
Right triangle.
Okay. So they know the vertical and horizontal distances because they got that in 6th grade. In 7th grade, they started talking about those proportional and non-proportional relationships, those graphs and what they look like. So now how does that apply, do you think, as we get into 8th grade, and now we're getting into lengths of the sides for triangles?
How does the proportional relationship apply?
Well, what we've done up to this point. So we did the horizontal, vertical, proportional, non-proportional, and how to get those things, right? So I know I'm only showing the number line, but there's ways that we represent these things in other ways. How does that impact them now finding side lengths for triangles?
Because you got that, you have the slide that's slanted. You got that hypotenuse right there that's slanted, and they have to be able to, it's not like the shortest distance between 2 points is a line.
Yes.
So when we're going that diagonal distance, it's not exactly 1 unit if I'm going from -1, 2 to -1, 1. You know what I'm saying? That's not the same distance as going from -1, 2 to 0, 2, or 0, 2. You see what I'm saying? So, and it's, of course, they would need a visual probably to understand what I'm saying. But when you talk about that slanted distance or that diagonal, it is now going to be a longer side when you go from grid line to grid line, versus if they are on the same horizontal line or the same vertical line, then a unit is a unit. If we go from 1 to 2, 2 to 3, -1 to -2, and so on and so forth.
So I know that I know you are using a different curriculum in Charlotte, but I know here we start off with dilations and then go into the similarity and slope triangle, and then progress into finding the slope of a line based off the similarity, and understanding that those relationships between each of those points, like you were saying earlier, are going to be equivalent. And then they eventually make their way to Pythagorean theorem and things like that. So I was trying to show the progression of all those different concepts that they're getting in 6th, 7th, and then now 8th grade, that kind of build up. So Akil, oh, go ahead, Dana, go ahead.
And to that point, you mentioned last week the Achieve the Core major frameworks, right? You just said something that made me think about it. What parents, most of the average parent doesn't know this, right? There are concepts that are introduced in 6th grade, and they don't see that concept again until 8th grade. And so the content in 8th grade is built with the assumption that the kid understands that content was introduced in the 6th grade. And you just kind of explained that in a way. So I think that's very, very important. Sometimes students will say, I've never seen this before. They just probably don't remember that it was introduced to them 2 years ago, possibly.
Yeah, because that's just like, I'm trying to think. When Akil was talking earlier about the equations of the vertical and the horizontal lines, I know they talk about it in 8th grade. We're not explicitly talking about that in 6th grade. And then I don't even know to what degree they're even talking about the vertical and horizontal lines in 7th grade. I feel like when they're talking about the graph and the equations of the line, it's more so proportional and non-proportional relationships versus vertical and horizontal equations of a line. So that might be an instance where the student was introduced to it in 6th grade. Then there's like this space of time where we're talking around it, but not at it directly. And then boom, back in 8th grade, we now have to pull from what we were introduced to in 6th grade.
Yes.
So then, okay, so my question would be, because as a parent, I'm not going to know all the intricacies. Now, obviously, I'll have the link to the major works of the grade level, but then how do I manage? What would be your advice for how I would manage maintaining those things are not going to be consistent, or just maintaining overall, especially if I'm at a school that's not giving out summer packets, because they ain't getting to my child. So
I think that goes back to practicing skills, right? There are certain skills that at each grade level, if your child practices them, they're always going to be prepared for the next grade level.
okay.
I think that I wouldn't worry about it as much until you get to that eighth grade topic to say, oh, okay, we need to go back and review A, B, and C, right?
Mm-hmm.
Because as a parent, you don't know what you don't know.
Right.
You know what I'm saying? And so a parent may say, they may want to be proactive and say, hey, I'm gonna reach out to DJ's teacher and ask him that question. Hey, what is going to be taught this year that won't be taught again until eighth grade? He might not even
They
know it.
might not know.
Like, that's where, as a parent, you kind of got to dig and you got to ask questions and you got to hit up Akil and Nisha and myself and all your teacher friends that are teaching mathematics, and not just anyone teaching mathematics. You got to go to a reliable source, somebody that you know really loves this, really lives it and breathes it, because
Yeah.
they're going to be thinking far beyond what the kids need just that year. I believe that in order to be a great math teacher, if I'm a eighth grade math teacher, in order for me to be great, I got to know the vertical alignment from seventh and sixth grade, as well as a piece of the vertical alignment from ninth grade.
Yeah. Yeah. And I think, I don't know, but I think maybe that might be some of the thought process behind a 6-9 certification, because that's the test that I took. So if you're middle grade certified, it's a
Yeah,
6-9. So I'm thinking maybe that's the thought process behind it. Like, you knowing your grade band. I could be wrong.
that might be the case. I could agree with that, because that's been way before Common Core. Like when I did my certification, I went ahead and just tested. I did the what's that crazy test? I don't like to think about it. I did
Praxis.
the praxis. I struggled so much with the high school praxis. I went and passed the 6 through 9 praxis, and then they gave me my high school certification based on my degree. So
Mm,
yeah, I agree. That probably is the thought process,
mm,
because you can teach middle school, and it's a couple teachers from our team that I was working with last year that were 6-9 certified, but they were able to teach Math 1.
mm.
I
Yeah,
always
that's
wondered
how I
about,
started to.
but at first, until I learned about the game, how there were certain teachers that I worked with in high schools that could only teach ninth grade, like they
Mhm,
never taught 10th, 11th, or 12th, because
mhm.
they had 6-9 cert.
Yep.
Yeah.
Okay. So again, we're almost at the end. We only have about 4 more slides. So again, we started with that number line in kindergarten, made our way up through eighth grade. Okay, we've talked about both sides of zero. We talked about the X and Y axis. We talked about the coordinate plane, plotting points, vertical distances, horizontal distances, slopes of lines, right? And now that we're having a good, we hope that kids have a good understanding of the coordinate plane or can reason spatially. Now we're talking about transformations. So now, looking at this image, what would we want kids to know or understand about what's presented?
What what's my pre-image and what's my image? Well,
Okay.
Ooh,
definition.
yes.
What is a pre-image and what is an image?
Okay.
Touchdown. Touchdown.
Yeah, which used to, like, it confused me, kind of confused me at first, because I'm thinking the original I'm thinking the original image should be the image. So I'm thinking maybe it should be an image and a post image.
because they kind of doing it like how they do with the movies. Like they come out with the movie and then they
It's
decide
the
to do.
prequel. Mhm.
Yes, I agree. And the notation for image and pre-image. The notation being, let's say the yellow triangle is the pre-image. So it's going to be labeled ABC.
Mhm.
So
Mhm.
triangle ABC goes through a transformation onto triangle DEF or triangle A prime, B prime, C prime.
Yep.
You see what I'm saying? So knowing what that notation looks like, and prime, for the parents that may not be familiar with that term, it's just like, for example, inches have 2 little tick marks and feet have 1. So when we talk about prime, it looks just like what Nisha is writing versus, so that would be on the image, but the pre-image would just be point A. So point A is mapped to point A prime.
And right, and so what do you mean by that when you say mapped? Like, what does that mean?
Ooh, I would say related to.
Okay, or like corresponds to, like
Yes, yep.
even that, like, well, now, so if I say that, now I got to define corresponds. Like, what does that mean in this context? So okay, so yeah, so all of this is important.
Okay. So looking at this, do you think that a student, even if they did not know the official academic terminology, that they would be able to give you something based on what it looks like? So if I said, let's just say I said this was the pre-image and the image. If a student walks in 8th grade and I tell them, what word would you use to describe the relationship between the pre-image and the image? Do you feel like they could come up with a term to describe that?
Absolutely.
What term do you think they would use? Put on your student hat, not on your I've been teaching for 87 years hat.
They both triangles, Mr. Harris.
Okay.
So
right.
they gonna say, or the average student probably would say, well, they look like they the same size.
Okay. All right.
So I think that they would talk in that terms. They will recognize absolutely that they're both triangles, but they'll say, oh, well, they look like they the same size. One's just flipped.
There we go. That's what I was seeing if you're gonna say that. Look like they.
I think I have some students that would sit in class, and if they don't have a lot of confidence, they might in their mind be thinking like, "Yo, these look like reflections of each other." But
Yes.
they're
Yep.
scared to say it. They might be scared to say it for fear of being wrong.
Mm.
But
So
they'll know.
they would actually. Now, what grade? You talking about college or you talking about eighth grade?
I was say any grade, like maybe
Oh,
8th
okay.
grade, maybe 7th grade.
You think they would say reflections? Okay, yeah, they might.
Somebody, maybe not everybody, maybe it might be 1 or 2 people in the room might look and say, that looks, you know.
So then,
Yeah, because mirror image.
right.
You see
Yeah.
what I'm saying?
Mhm.
And that's yeah, I love that, because somebody might say mirror image, but somebody also might think the same thing that Akil just said.
Mhm.
Because they may not recognize how mirror image is relevant in math class depending on their level of understanding.
Mhm. So then, talking about that, how is mirror image relevant in this classroom? So now, what should I recognize about those points? What should that student recognize about those points that takes it back to the mirror image?
One of the coordinates will be the same.
Okay. All right. Because they're on a horizontal line. Okay.
Yes. And
All
when
right.
we say coordinate, let's not get that confused with ordered pair.
Okay. Yeah. Mm-hmm.
Parents, please remember a coordinate. There's a X coordinate and a Y coordinate, and we put them together in parentheses to create an ordered pair.
Yeah.
Okay.
If it is in fact the reflection, those points, those corresponding points, they have to be they're going to be equidistant or just as far away from the mirror that we're using. because the thing I like to talk about when I talk about reflections and transformations is like, what if it's a reflection, there's got to be a mirror.
Mm-hmm.
Like, what is your mirror? Or what is our mirror? Is our mirror the x-axis? Is our mirror the y-axis? Is our mirror some other line that's drawn on the coordinate plane? Like, what is our mirror? And then I even talk about, like, I told a student, like, when you look at yourself in the mirror, it looks like the image in the mirror when you're seeing yourself in the morning and brushing your teeth, it looks like you're just as far away from the mirror, like in the mirror, as you are from where you stay.
Mm-hmm.
To try to get them to like visualize what's going on, like to try to apply it to this situation, apply that concept of like a reflection to this situation on the X.
All right, so same thing. Student walks in, we put this on the board. What are we expecting them to say?
A slide.
Yeah.
Okay. Okay. So then is there anything else that we would want them to add on to that?
They need to definitely recognize it's the same size.
Okay.
Same size. I think an important piece that kids often overlook is that when we talked about corresponding points, right, or corresponding vertices, and so let's go directional. The bottom left corner of that yellow triangle, it corresponds to the bottom left corner of the right triangle. So when we talk about how far this triangle has made a slide, we need to go from corresponding point to corresponding point. And they all should be the same when it's just a translation.
Okay. Okay. All right. And I know sometimes we get into what that looks like when we have like a rule for the transformation. We might have X plus whatever, or X minus whatever as well. So the
Yes.
kids will eventually get to that. All right, bet. And here.
Ooh. It's a windmill, Mr. Harris. That's what they gonna say. That looked like the windmill I bought at the store the other day.
That's spelled it right.
Yep.
Okay.
It's
All
gonna
right.
be right today.
Okay, sweet. All right. Anything else? We got, they said it looks like a windmill. Anything else we expect?
I think they'll say like it's turning from quadrant to quadrant.
Okay.
So is this a 90-degree rotation?
Is it? Is there one here?
It's a rotation. It's a 90-degree rotation about the origin.
About the origin. Okay.
Is that right, Niche? Am I right?
Yes.
All right,
In North Carolina,
had to make sure.
in North Carolina, we are limited to the origin being our center. And we are also limited to 90-degree increments as well. So I've only labeled 2 of these triangles. White is pre-image, and then yellow for this particular question is going to be our image. So then we already said that the whole thing looks like a windmill. The whole thing looks like we're turning from quadrant to quadrant. But if I just focus on the ones that I've labeled, what do we want students to understand or pick out?
It turns counterclockwise. We need to recognize clockwise and counterclockwise.
Yeah. And know what that means.
Yes.
So if you didn't learn how to tell time using an analog clock, that's something we can't take that for granted. Yeah.
That part.
That's man. Ooh, that's one that, and that's, I truly believe that's why many of the students struggle with the clockwise and counterclockwise piece, because they got cell phones in their pockets, and there's not a lot of focus on telling time on an analog clock in school.
Right.
Yeah.
So that's where all this math at home come into play.
Facts.
Yeah.
Now I'm gonna tell y'all, whenever We don't do this in Math 1. So when I came to middle school, I didn't teach 8th grade, but because I am extra, I wanted to know, I was teaching 7th grade, so I wanted to know what it was going to in 8th grade and what they came from in 6th grade. And so when I would look at transformations, everybody that I went to on YouTube was like, memorize these rules. And the rules was not clicking for me. I'm not a rule person. Like, I need to understand what we talking about here. What is the nitty gritty? And so for me, I thought about, if I'm doing a 90-degree rotation, whatever was my, like, if I think about it in terms of a triangle, whatever was my base is going to become my height, and whatever my height is going to become my base. Like, that's how I made sense of it in my mind. And when I go into a classroom, I do the same thing. Like, I take a pencil and I say a 90-degree rotation, what happens? What happens? And then the kids usually can get it. And then I started looking at, oh, if I look at corresponding points, and if I were to have like a little pin in the middle, and I took a string and a pencil and I drew them and connected them, it would make a circle. So then I had to do all these things to make it make sense in my brain. And I would talk to my colleagues and they'd be like, what you talking about? But this is what I had to do to make it make sense for me, because I'm not don't just give me no rule, because it's going to be hard for me to remember the rule if I don't understand the concept.
Yeah.
But I think I always tell you, that's why I believe you're such a great math coach and math teacher, because you didn't come into this thing like just always having this affinity for mathematics like I did. So I was stuck on the other side of the tracks. Like, hey, this the rule, man. Like, because it just is. And I had to go into my bag. I remember one of my courses for my licensure was a geometry course, and it was all proofs. But we didn't get into no deep, thorough geometry. We stuck with the basics. Proving shapes are what they are, proving things to be parallel. I think the most difficult thing that we got into was Pythagorean theorem. And that's what helped me start thinking from the other side. Proofs, as much as I hated them, I had to think from the perspective of the person like you that says, wait, no, I need to be shown more than just y2 minus y1 squared equals x2 minus, that kind of stuff. Yeah. Because I could stack all those things in my mind.
I think that was the reason why I enjoyed talking with you so much, because we had different viewpoints. And I feel like when they came together, like, it opened up a lot for me.
And me as well.
What were you gonna say, Akil?
I was gonna say, man, old habits die hard. Like, I'm an algorithm based person, so especially like when we talk, like, I feel like a sense of relief. Like, for the rotations, it's a formula. All I gotta do is, okay, 90 degrees clockwise is this, 270 degrees counter. Okay, cool. Like, again, it's like I'm going back to video games from like '88. I'm like, okay, this is the cheat code, right? That's how I looked at it. I'm trying to get away from using, like I talked about in the chat, I'm trying to get away from using the term cheat code to describe strategy in math. But I think this is a time when it's appropriate to describe it that way. But yeah, like, so yeah, old habits die hard for me. I'm big on, like, with the rotations, just knowing, just memorizing, like, what happens to the X, what happens to the Y. It does. I would like to look into, Lanisha, what you're talking about like the conceptual way to understand it, because, I forget them. Like, that's another thing. Like, I forget them. Like, it's a lot of stuff, and I think that is one of the drawbacks to being algorithm based person, is a lot of stuff I just forget. Like, over the years, how many times, like, I've forgotten, I have to look up, like, the special right triangle relationships and 30, 60, 90 triangles.
Yeah.
Like, until I started to see, okay, like, this is why these sides are related to each other like that. Then I could figure it out. But until I started doing that, I would always forget them. I would always forget, like, the relationship between the sides, and I'd have to always look them up. And I'll be like, I have to always look this up. Like, I learned this, like, when I was in 10th grade. Like, why do I have to still look this up? Like, it seems like every time I need to, engage with it or teach it or tutor it or whatever. But the conceptual does help. But I don't know. You just feel comfortable. Like, I don't know. It's like Linus's blanket or something, man. Like, those algorithms.
Yeah. For me with this, I just know what happens with the 90 degrees, whether it's clockwise or counterclockwise. If I know what happens with the 90 degrees, I can figure out everything else because I know whatever my pre-image is, 180 is going to be opposite of that. And
Right.
then whatever my 90 degree is, if I go 90 degrees counterclockwise, 270 degrees is going to be the opposite of that. So like understanding, if I just know 90 degrees, I can figure out every single thing else. And that's how, like when I'm tutoring students or working in small groups, I do the exact same thing with them.
I use that with the unit circle.
Yeah. Yeah.
See, look at that. Connections. All right, last thing, and then we wrapping it up. So students see this. The white is my pre, my yellow is my image. What are we expecting them to notice, see, hear?
That
But
there's an overlapping.
Okay.
Is the image just the yellow part, or is the image the white part connected to the yellow part?
So they're both triangles. They're both right triangles.
But you see what I'm saying? Like, so the pre-image is the small white triangle. And then, right, so what you outline is because I've seen that on tests where they compare the small triangle to what ends up being, assuming, a trapezoid.
Yes, and they got an answer for the kid that assumes that is a trapezoid.
Yeah. So that outline is helpful just to show. But I think it's helpful for the child to be able to visualize those two triangles being separated from each other.
Right. That's that
True.
spatial piece.
Yeah.
But I think, and I could be wrong, I think I did take a class once on test item writing that they would name the triangle. So they would say, we're comparing triangle ABC to A prime, B prime, C prime, whatever, so that the kids would know that the two images that they're looking at are both right triangles.
Yeah, they would have to do that, definitely.
Yeah. All right, so Dana said they're overlapping. What else we got?
This is something unrelated to this specific problem, but when you talked about naming triangles, you made me think about something. Maybe it's something for us to talk about in the future, but just how to name angles. Because there's so many ways to name angles. Like if we have an angle, and if there's a vertex that has that is part of multiple angles, like that whole concept. Because a child or a person will look at a vertex and see, oh, well, that's angle A. But angle A is the vertex for like 4 different angles.
Right.
So if you call that angle A, which angle are you talking about?
Right.
Like, what are we talking about? That just came to mind.
I think that's good, because that reminds me, you just made me think about it. There might be a child that says, oh, okay, well, if they share that vertex at the bottom left, then the white triangle may have been stretched from that point. And they just stretched the bottom leg as well as the hypotenuse. You know what I'm saying? Which then now if they stretch those two, it's the same angle, but wait, it's further away from the connection on that vertical line on the right side of the white triangle. So then that means it has to be stretched that the vertical side of the yellow one too.
Yeah. All right. Anything else? So we got overlapping, we got stretch. Now, one thing that we didn't talk about for the other 3 was congruence, or well, no, we did, because you did say that they were the same shape. Dana, you did say that. Okay. So with that being the case for this one, you just said that they would have the same angle. So then what terminology would we expect students to use when they're comparing these 2 shapes? The angles are congruent, but what are the shapes to each other?
I don't know that they're going to assume proportional, because that's based on their level of knowledge, but that would be the goal, to get them to understand that they're proportional.
The proportional side lengths. And then what did you say, Akil?
I was gonna say, like, the sides of the triangles. All about those relationships.
Okay.
And then, but I guess if they have it would be helpful if they understand fractions really well. if they have a conceptual understanding of equivalent fractions.
Ooh, that's good.
That'd be helpful. But also what I think is key too is like how you can show the proportionality using different fractions. Like you could say, like, 'cause sometimes like we'll do like the numerator in the proportion, the numerator might be the base of the little triangle, and the denominator will be the base of the big triangle.
Right.
It's to right side of the little triangle over right side of the big triangle.
Right.
But might also, I think it's important for them to know you also could compare it. One fraction could compare two sides of one of the triangles. So you could do base little as your numerator over right side little. And then that would be to base big over right side big. And then you get into, okay, well, why does that work? Because then we can get conceptual with it, which is something I'm still like kind of trying to wrap my head around sometimes. Because a while back we talked about the cross product property and why that works. Like, why does that end up making sense? Because you're actually multiplying by the same number on both sides. So like cross multiplication is like a shortcut, basically.
Right.
Because Lanisha, you brought this up in one of our sessions earlier, a few months ago. So that's bringing us back to that.
One thing I want to highlight before we wrap is that in 6th grade, students scale ratios. In 7th grade, students are scaling like dimensions, I guess you can say. Like, I can give you a scale factor, like 1 centimeter represents, I don't know, 5 meters, whatever the case may be, right? They're scaling those. And then now we're in 8th grade where they're scaling side lengths as we start to talk about dilations. So that scale term has literally followed them since 6th grade. They're just seeing it in different situations or scenarios. So with that being the case, it's almost 9:30. We have these last 2 sessions. So all of July, we've been talking about the progression of the number line from kindergarten all the way up to 8th grade. And Dana and Akil have highlighted that obviously it goes far beyond that, because all of this stuff is really exposing the kids and preparing them to work with those higher level mathematics. We've even went as far as giving parents ways that they can work on the coordinate plane at home, in your neighborhoods, in your house, using your window panes, maybe even your blinds or the tiles on your floor. So as we get ready to wrap up, I want to hear from Dana. I want to hear from Akil. What do we want to leave parents with beyond the things that we've already shared that can really equip them and empower them to go forth and take this progression and really help their kids as we move into a new school year?
I say always think outside the box. And y'all know I am an advocate of playing on what your child enjoys doing and finding a way to extract the mathematics from it. So when we talk about those different strategies that we use, whatever it is that your kid is into, find some way, somehow. There's almost always a way that you can extract mathematics from it, even if it's indirectly. You know what I'm saying? If you want to use, instead of variables, you want to use characters from their favorite cartoon or their favorite whatever it is that they like, then do that. And that'll always give them buy-in most cases. Because sometimes you can have mind control over Debo and they don't even know they doing mathematics. You know what I'm saying?
Thank you.
Yeah, I would say this. I would say to parents, I know like it becomes like daunting. A lot of things become daunting like when you have never really done it. But immersion is so helpful. Just immerse yourself in the math. And what I mean is like maybe just don't even worry about really, if you're just starting out as a parent and you want to become more active in terms of your, facilitating your child's mathematics education, just don't even worry about really understanding it necessarily at first, but just like immerse yourself, like, listen to some podcasts about math, watch watch some movies, some Hollywood movies, maybe like Stand and Deliver, Beautiful Mind, whatever. you know, just kind of immerse yourself in the language. You're going to start hearing the same terms over and over again, and it's going to become normalized to you. And then you'll just start to randomly just start to notice stuff. Like a lot of the stuff that we talk about, that's second nature to us, you as a parent, if you're watching this and listening to this, it'll start to make sense to you, you know? And as I sit here in this room and I'm looking at this flat TV that's installed on the wall, I'm thinking about what we were talking about tonight about the XY coordinate plane, and like how this corner, I'm looking at this corner of this TV, and how that's like the first quadrant, or the TV itself, the TV screen itself. I'm visualizing that as like the first quadrant of the XY coordinate plane. You know, where the x-axis is the horizontal part of the TV, the y-axis is the vertical part of the TV, and the screen itself is the first quadrant. So then, you know, you just start seeing things. Once you start just recognizing the map, it's like a Rorschach ink blot. Once you start seeing it for yourself in places that you never saw before, that's when you know you're on the right track. And then it's just going to continue to happen. And it's almost like one of those things, like once you see it, you can't unsee it.
Mm-hmm.
You're going to keep seeing the math. And if you keep seeing the math, that's when you're going to start to feel like you could do it. Because a lot of us, if you're an adult and you feel like you had a negative experience in math class as a child, it's a large part of it was probably because you couldn't see the math. You couldn't see it in your everyday life. It was very abstract, and it was like something that somebody was trying to force on you while you were sitting in that classroom for that hour or that 45 minutes. That's why it seemed irrelevant.
Right.
But
Yeah.
once you start to see it everywhere around you, you're like, yo, okay, I get it now. Like this how you're going to use that. Oh, damn, like I wish I would have knew that like 30 years ago or 20 years ago. Like now I get it now. You know, and that's sometimes it's the immersion. The immersion is what leads us to that, you know, but that's with anything, any topic, you know, anything that you're studying or trying to learn or get better at, you know? So yeah, just for parents, just immerse yourself, just relax, don't stress, don't expect to like become a seasoned math scholar in like 2 weeks or 3 weeks or like even 2 or 3 months, or even, you know, just give yourself grace and take time and just immerse yourself in it and just stay consistent and just be committed to just learning with your child. That's what I want to say.
All right. So one thing that I heard you say in there last week, we talked about a myth that we busted, which was about the y equals mx plus b and people feeling like I went another day without using it. And I think it is the absence of being able to see where we use it that makes it seem like something that we're so detached from. So just like Akil said, looking around you and seeing all the places where these concepts show up, and the whole mind control over depot, using what you got to really learn what you know that your kids need to learn. Like use the things around your house. Both of you guys, all of us, have given off different examples of things that we can use in our house, in our neighborhoods, in our cities to help with specific concepts. So get mind control over them kids, and sometimes mind control over yourself to realize that it's really at your fingertips. Like you don't really have to do a lot. You really can just walk out your house, look around your house, and it's all there. So that's where that immersion comes from. And then also immerse yourself in math media. So books, podcasts, movies, things like that. And so that you are, you know, learning more of the language. Like Akil said, it's going to be more consistent because you're going to hear things over and over again. So, you know, I like to repeat what y'all said because it helps me to remember it. So my one thing that I want to say is to be proactive, because I feel like when we do things in a reactive nature, it is overwhelming. Because with everything else in life, if I am now at the last minute realize that little Timmy has a test on Friday and I'm trying to figure out things to do to prepare little Timmy for that test, it's going to feel like a lot. But if I already have a schedule planned out, if I already have a plan for how I'm keeping up with what's going on with little Timmy in school, how I'm keeping up with what he's engaging in, I'm already setting an example for how he can use his resources online or wherever else to prepare himself, then it's not as much stress on me. So that's going to be my thing that I'm going to leave y'all with as we wrap up July, is to be proactive. look ahead. Don't wait to the last minute because it's just stressful for everybody. Don't wait for nobody to give you nothing. Don't wait for no summer packets. Go out there and get what you need. You know, mind control over yourself and your kids. Immerse yourself in all the things that you need. Thank you guys so much for joining us this evening. Thank you, Dana and Akil, for sitting down with me and helping us all tap into our math genius. I really do feel like that we're more than capable of excelling in all this math because we all are young gurus, and I feel like we all can bud and bear fruit. So until next time, I want you guys to be
Deuces.
peace.
Peace.